Hi, my name is Taylor Robinson, and this is my summary video. So the first thing to discuss is misconceptions, what they are. So to me, a misconception is like an opinion or a preconceived notion that's not true based on either incorrect thinking or incorrect understanding. Two examples of this that are common are there is a dark side of the moon, and the moon is only visible at night. So if my students have misconceptions, the way I will leverage it in my future classroom is by having my students first identify the misconception that they have, and then I will help guide my students in reconstructing their learning or knowledge about that topic by doing research and evidence and probably doing experiments about it. I want them to see why their misconception was false, and then what is the truth, and then how we got to the truth. So the progression of standards. The progression of standard means that within each standard there's a topic, and that topic builds on itself throughout the course of the grade level. So as the grades go up, there are more components to that standard, more things to learn. They become more complex, more to investigate. So one linear progression is LS4.D, and it's about biodiversity in humans. So kindergarten, first and second grade, what they'll be learning about is a range of different organisms live in different places. Third grade, fourth grade, and fifth grade will learn populations of organisms live in a variety of habitats. Change in those habitats affects the organisms that live there. And then sixth grade, seventh grade, and eighth grade will learn changes in biodiversity can influence humans' resources and ecosystems that they rely on. So, the 5th grade PS1-3 standard talks about making observations and measurements to identify materials based on their properties. So a clarifying example of this would be properties include color, hardness, thermal conductivity, and responsiveness to magnetic forces. There are other examples of this. Those are just a couple that I picked so we kind of get a background of what we're talking about. Knowledge that the students should have about this topic before they enter 5th grade would be 1. Matter exists as different substances that have observable different properties. 2. Different properties have different purposes. 3. Objects are built up of smaller parts. And 4. Matter exists as particles that are too small to see. So after they go through my 5th grade class, they will continue to learn about this topic 6th through 12th grade and probably beyond. But after 5th grade, this is what they will learn. Matter is composed of atoms and molecules. This can be used to explain the properties of substances, state of matter, diversity of materials, and conservation of matter. They will also learn about how interactions between electric charges at the atomic scale can be used to explain the structure and interaction of matter. So, moving on to the 5E learning cycle. The first stage is the engage stage. So these are the things that we want to happen during that stage. The learning outcomes for this stage is to, most importantly, pique the students' interest in the topic and also make it something that's relatable to their daily lives. Make sure what you're teaching kindergarten relates to kindergartens, what you're teaching freshmen in high school relates to their lives as well. The teacher identifies what the students already know about this topic, and some questions that the student asks themselves are like, why did this thing happen? Which is why we do more research on it later on in the 5E learning cycle. So the second stage is the explore stage. The desired outcome for this stage is for students to test their predictions and hypotheses they make about the subject, form new predictions and hypotheses, try alternatives, and allow the students to think freely about the subject. Let them come up with their own explanation, their own thinking, do their own project, whatever way they want to. The teacher should ask probing questions to redirect students' investigation when it's appropriate and give enough time for students to do the trial and error process. So Dustin always tells us it's okay to be a little frustrated at this point, and it's okay also if they do it completely wrong. We shouldn't jump in and tell them that they're wrong. This is for them to explore, hence why it's called the explore stage. The third stage is the explain stage. The desired outcome for this is for students to explain their possible solutions and hypotheses to others, kind of explain what they did in the previous stage. Students should ask questions based on other students' explanations and then use this time to think about what they had done and how they can make it better and how they can improve it for the next stage. The fourth stage is the elaborate stage. The desired outcome for this stage is to apply the new information they learned in the previous stage and apply new skills to a similar project that they had just done in the explore stage. Use previous information to ask questions and make decisions. Students should be feeling more confident in their abilities at this point and beginning to kind of understand the concept, and everything should be coming full circle. So stage 5 is the evaluate stage. The desired outcome for this stage is students are able to demonstrate an understanding of what they've learned in some form of assessment, whether that be a written test, a project, a debate, a poster, a song, a rap, really whatever you want to do, as long as it's testing what your objective was and it goes along with your lesson. So, examples of 5E activities. Something you could do for the engage is read a few pages from a book about animal features and show a short clip about animals in their habitat. For the explore, I would have students research an animal and make a T-chart and have 5 physical features on one side, 5 physical features of the animal on one side, and then on the other side of the T-chart, how those specific features help the animal function and survive in their habitat. For the explain part, I would introduce new vocabulary such as like camouflage, hibernation, and things like that, and ask students questions about the activity they just did and how those structures resemble structures that humans have and what we use them for. So now that I introduced that, in my elaborate stage, I would have students make a poster that shows one function, such as like protection, for example. They would show how an animal uses protection or what physical features they use for protection and what humans use for protection. So an example of this would be like a turtle uses its shell for protection, just like we humans use like clothing for protection. So for the evaluate stage, I would have students match picture cards to show like a human structure and an animal structure performing the same function, referring back to like that protection example. And the engineering design process. The engineering design process exposes students to a new way of problem solving. The steps are ask, imagine, plan, create, and improve. This process utilizes skills, which are great for students. Skills like critical thinking, teamwork, creativity, and most importantly, problem solving. I believe that the deep learning occurs in the improve process because students have to think critically and go back, think about what they did, why it didn't work, and then find a solution, try that solution, then if that doesn't work, determine why it didn't work, find another one. So I feel like it's more of the critical thinking stage. And they can go back and reflect and replan, and all of those things are important in science. So an example of this would be doing a paper airplane, seeing how you get a paper airplane to travel the farthest distance. So anyone can make a paper airplane, but can we make it go far? We don't know, we'll have to see. So after it goes as far as it can, we want the students to go back and reevaluate their paper airplane. Some things they could ask themselves was like, maybe there was too much weight on it, maybe I didn't use the right kind of paper, are my wings wide enough, is it narrow enough? Those things are things I want them to think about, and then go back and improve on their paper airplane, and then try it again. So lastly, some feedback about the course. So the assignment that I think was the most helpful and impactful was the foldable and the newsletter, because those are things that I will definitely use in my classroom. We'll make foldables for reviews, flashcards, really for any subject. And then the newsletter was great to practice because I haven't practiced one yet in college, and I'll be making a lot of those to send home to my parents. So I thought those were great, and I actually enjoyed it. It was very creative and fun. So the assignment that I didn't feel like was super helpful was the big unit plan, only because we had been doing 5E lesson plans all semester. We did a group teach one, we did them in our practicum classes, we would do them during class, we would do parts of them during class, we watched other people do theirs, we did our own. I just feel like we had enough practice with it, and it was so big that it was extremely long and kind of overwhelming, and this wasn't something that I really enjoyed doing or looked forward to doing. Maybe if it was just two, you just had to make 2 lessons, it would have been more manageable than doing the third. But yeah, overall I thought the semester was great. I enjoyed the class, and I'm excited to see what else I'll be learning next semester.